Usually when we talk about like a new coworker joining the office, you kind of know what to expect.
Right, you figure out their baseline pretty quickly.
Exactly. Maybe they build a great financial model, but they completely freeze up when they have to present it in a meeting.
Yeah, standard office dynamics.
Right. But imagine you get a new colleague, and on their very first day, they just stroll into the medical department and start flawlessly diagnosing complex diseases from, 1,000-page case files in seconds.
Oh, wow.
And then right after lunch, they wander over to the creative department and paint an absolute masterpiece, like an undiscovered Renaissance classic.
Effortlessly.
Yeah. All the while, human resources sitting in a back office frantically sweating over this person's background check because they have absolutely zero idea how this entity is pulling any of this off.
It is, it's the ultimate unpredictable prodigy. You're entirely thrilled by the output, but completely bewildered by the internal mechanism generating it.
Welcome to today's Deep Dive. I'm your host, and today you are getting a snapshot of our current technological landscape.
And I'm thrilled to be here to help break it all down.
Specifically, we are looking at source material dated May 3, 2026. The mission for our deep dive today is to explore the sheer breakneck speed at which AI is currently reshaping the architecture of our world.
It really is moving at an incredible pace.
It is. We're looking at three interconnected areas: healthcare, art, and the underlying ethics of the algorithms themselves, to figure out the mechanics of this shift and what it actually means for your daily life.
Which is, everything right now.
Okay, let's unpack this. Because to ground ourselves, we really have to start with the stakes. And the stakes just don't get much higher than human health.
No, they don't.
Our sources are highlighting a massive breakthrough in early cancer detection.
And looking at the mechanics of this breakthrough, it really strips away the science fiction. It shows us the immediate, practical application of modern neural networks.
So what are we actually looking at here?
Well, researchers have deployed a new AI model that analyzes multidimensional medical imaging with a level of statistical accuracy that it just surpasses our historical benchmarks. We are talking about analyzing 3D MRI and CT scans.
Well, let's look at the underlying process, because it isn't just looking at a flat picture the way a human doctor slaps an X-ray on a light board, right?
No, not at all.
The sources note it is training on a massive data set of patient scans. But how is it actually, seeing these images differently than a highly trained radiologist?
What's fascinating here is the fundamental divergence in how biological vision and machine vision operate.
Okay, break that down for me.
So when a human radiologist reviews a scan, they are relying on years of medical training, but they are also constrained by the biological limits of the human eye.
Right, the physical hardware.
Exactly. We have foveal vision constraints, contrast resolution limits, and, frankly, cognitive fatigue.
Which is a huge factor.
Huge. If a doctor is on hour 11 of a shift, their brain is physically filtering out subtle information just to conserve energy.
Wow, yeah, that makes sense.
But this AI model doesn't experience cognitive load. It doesn't even see an image in the traditional sense.
What is it doing then?
It analyzes a multidimensional matrix of data points, what we call voxels in 3D imaging. It is running pixel-level contrast analysis, looking for microscopic mathematical anomalies in the tissue density.
Wait, so things that a human couldn't see even if they were fully rested?
Exactly. Anomalies that simply do not register in the visible light spectrum for a human eye.
So it is identifying the mathematical signature of a disease long before that disease manifests as a visible shadow on a lung.
Yeah, it is quantifying the tissue structure. And if we look at the why behind this deployment, the core objective isn't merely speed.
Right, speed is just a bonus.
Speed is just a byproduct of computational power. The objective is increasing survival rates through aggressive early intervention.
Because if you catch it early, everything changes.
Precisely. If the AI can instantly parse a massive queue of incoming hospital scans and algorithmically bump the most statistically concerning anomalies to the top of the radiologist's list, you completely restructure the triage workflow.
You are basically weaponizing efficiency to save lives.
That's a great way to put it.
Well, let me push back on that, because reading these sources, I think you listening might be wondering the exact same thing I am.
Okay, what's that?
If we have this tireless, mathematically superior cancer-detecting architecture that catches anomalies human biology literally cannot see, why isn't this running in every single hospital right now?
That is the friction point where cutting-edge theory slams into the wall of legacy reality.
The real world gets in the way.
Always. The healthcare system's infrastructure simply wasn't built for interoperability with massive neural networks. You are dealing with highly rigid, deeply entrenched digital frameworks.
Like the Rickon systems.
Yes. Hospitals run on proprietary electronic health record systems, or
Mhm.
EHRs, many of which are using database architectures from, like, a decade ago.
It's like trying to run a top-tier PlayStation 5 game on a 1990s graphing calculator.
Exactly.
The calculator doesn't even have the ports to accept the data, let alone the processing power to render it.
The architecture mismatch is staggering. You cannot just deploy a cloud-based, multi-billion parameter AI model into a localized hospital intranet.
I imagine security is a nightmare, too.
Oh, absolutely. And beyond the hardware interoperability, the sources highlight a massive bottleneck in data logistics and compliance.
Because of privacy laws.
Right. To maintain the accuracy of these models, they require continuous feeding of sensitive patient data, ensuring the anonymization of that data, maintaining strict privacy compliance like HIPAA, and protecting these massive pipelines from cyber threats. It is a monumental engineering challenge.
So it's not the AI holding us back.
No, the delay isn't the capability of the AI, it is the friction of safely integrating a dynamic learning algorithm into a rigid, human-built system that is basically allergic to sudden changes.
The software is living in 2026, but the hospital infrastructure is stuck in 2012.
That sums it up perfectly.
That makes perfect sense. But looking at the source material, there is a distinct through line connecting this objective medical science to a completely different domain.
Yes, there is.
The underlying pattern recognition architecture, like the exact same neural network mechanics that analyze the geometry of a tumor, is being inverted.
Right.
Instead of just analyzing patterns, the AI is now generating them.
Yeah.
It's moving into a space we traditionally consider inherently human and subjective, which is art.
We are moving from the rigorous, quantifiable confines of medical data into the boundless, highly subjective realm of human creativity, yeah.
It's wild to think about.
The same foundational machine learning principles apply, but the output is fundamentally different.
Here's where it gets really interesting, because the sources outline recent, highly publicized projects where AI systems are essentially collaborating with human artists.
Right.
These models are trained on vast data sets of historical artworks. But we aren't just talking about a machine learning to, like, copy and paste a Van Gogh sunflower.
No, it's much deeper than that.
It is mathematically analyzing the brushstrokes, the lighting gradients, the geometric composition of thousands of artists, and mapping all of that into what developers call a latent space.
Think of a latent space as an incredibly vast, multi-dimensional library where concepts are stored as mathematical coordinates.
Okay, coordinates.
Yeah, so the AI learns the distance between the concept of a turbulent ocean and the concept of impressionist brushstrokes.
Right. So when a human user prompts the AI, the machine isn't fetching an existing image from a database.
Not at all.
It is navigating that mathematical library to generate an entirely new, bespoke image that matches the coordinates of the prompt.
Exactly.
When I read the mechanics of this, my mind immediately went to the backlash against the music synthesizer in the 1970s, or even the invention of the camera in the 1800s.
The historical parallels are incredibly strong. The disruption of established artistic mediums always triggers resistance.
Because when the camera was invented, traditional portrait painters were absolutely outraged.
Oh, they hated it.
They argued that a machine mechanically capturing light on a chemical plate lacked a human soul. It was parlor trick, not art.
And I saw the same thing with music.
Exactly. When the synthesizer hit the mainstream, purists claimed it was just automated circuitry making noise. It didn't require the breath or the physical calluses of a real musician.
Right.
But looking back, the camera didn't kill art. It spawned entirely new mediums like cinema and fine art photography.
And the synthesizer created entire genres of electronic music.
The machine became an instrument.
If we connect this to the bigger picture, your camera analogy perfectly frames the ongoing debate highlighted in the text.
Okay, let's get into the debate.
The sources detail two distinct, highly polarized viewpoints regarding AI-generated art, and it's vital we examine the mechanics of both arguments impartially.
So who's on the first side?
On one side, you have the purists. Their argument fundamentally centers on the definition of art as an expression of the human condition.
Meaning it requires our lived experience.
Yes. They argue that art requires mortal context, our experiences of pain, joy, and mortality.
Because an algorithm doesn't have a heartbeat.
Exactly.
He doesn't fear death. It has never fallen in love. So how can it possibly express those concepts?
That is their exact premise. They argue the AI is mapping the semantic relationship between words and pixels, but it fundamentally lacks the emotional context of those words.
It's just a really good illusion.
It is sophisticated mimicry. It might generate an aesthetically flawless painting of a weeping face, but because the AI has never experienced grief, the purists argue the resulting image is devoid of true emotional depth.
But the proponents of this tech, the artists actually using these models, argue the exact opposite, right?
They do. They don't view the algorithm as an autonomous, independent creator.
What do they see it as?
They view it as a collaborative engine. They see it as an expansion of human capability.
Interesting.
In their view, the locus of creativity isn't the physical act of applying paint to canvas. The creativity lives in the initial conceptual spark.
So the idea itself is the art.
Yes. The human artist provides the prompt, the iterative direction, the conceptual framework. The human is the director, and the AI is the deeply capable production crew executing the vision.
Which opens it up to so many more people.
Proponents argue this fusion democratizes artistic expression. If you have a brilliant visual concept but lack the physical motor skills to paint it, well, this tool bridges the gap between your imagination and reality.
It completely destabilizes how we define human ingenuity.
It really does.
Is the value of a painting the countless hours of manual labor required to produce it? Or is the value the emotional reaction it provokes in the viewer?
That's the million-dollar question.
Right. If a piece of AI-generated art makes you cry, does the fact that it was rendered by a tensor processing unit in 3 seconds invalidate your tears?
It forces a massive philosophical reckoning. We are having to separate the aesthetic value of an object from the mechanical process of its creation.
It is a massive conceptual shift. But as we look at both of these models, the medical AI analyzing voxels for tumors and the artistic AI navigating a multidimensional latent space to paint a sunset, there is a glaring common denominator.
The fuel running the whole system.
Yes. The underlying engine powering both of these systems is their training data.
Absolutely.
The medical AI needs millions of patient files. The art AI needs millions of high-resolution images. They are entirely reliant on the data sets we feed them, which brings us to the shared vulnerability outlined in our sources.
The ethical mechanics of data bias.
Exactly.
It is the foundational structural flaw of machine learning. If the data set contains anomalies, the entire predictive structure built on top of it is fundamentally compromised.
So what does this all mean? The sources point out that as these AI systems are integrated into more high-stakes environments like loan approvals, hiring software, and medical triage, we are running into a massive data fidelity problem.
Because an AI doesn't understand context.
Right. The data we feed it is essentially a highly compressed mirror reflecting human history.
And human history is, well, it's riddled with statistical inequalities.
So how does that play out in the code?
Let's break down the actual mechanics of how bias physically embeds itself into a neural network.
Yeah, let's do that.
An AI algorithm is, at its core, an optimization engine. It looks at historical data, identifies the statistical correlations, and assumes that future decisions should follow those same correlations to achieve the highest success rate.
Okay, so it just wants to win the game based on past rules.
Yes. It has no moral compass. It only has feature weight.
Feature weights, meaning like how much importance the algorithm gives to a specific piece of data when making a decision.
Correct. So imagine a medical AI trained on 50 years of hospital data.
Okay.
If that hospital historically underserved a specific demographic, meaning that demographic had less access to preventative care and consequently worse health outcomes, the AI algorithm sees that statistical trend.
But it doesn't know the context.
Exactly. It doesn't know why the outcomes are worse. It just sees the correlation. So the algorithm might assign a lower feature weight to the survival probability of that demographic and systematically deprioritize their scans in the triage queue.
Wow. That is incredibly dangerous.
What is?
The AI looks at the skewed data and concludes, this demographic naturally has worse outcomes, so I will optimize my recommendations based on that assumption.
Yes.
It completely fails to realize the data itself is skewed by historical prejudice or, socioeconomic factors.
It mathematically codifies human flaws. And the danger is the disguise of objectivity.
What do you mean by that?
Well, when a human doctor makes a biased decision, we can question their judgment. But When a machine outputs a triage list, humans have a natural tendency toward automation bias.
We just trust the computer.
Right. We assume the cold, hard mathematics must be objective and perfectly rational. Once historical inequality is baked into an algorithmic model, it becomes a systemic feedback loop that is incredibly difficult to untangle.
If you're listening to this, you might be realizing the sheer scale of this problem.
It's massive.
If the AI is just a highly efficient mirror reflecting our own flawed, historically biased data back at us, how do you engineer a fix?
That is the big question.
How do you mathematically teach a machine to be fairer than the reality it learns from, especially when these models are processing billions of data points? I mean, you can't just go in and manually edit the code.
No, you can't. This raises an important question, and it is the central engineering challenge the tech sector is currently grappling with.
So what's the solution?
According to our sources, the industry's primary pivot is toward the development of explainable AI, or XAI.
Explainable AI.
Yes. The push is to create transparent algorithms.
Explainable algorithms. The idea being that the AI can't just spit out a final answer. It actually has to show its mathematical work.
Exactly the concept. Historically, deep learning models have functioned as black boxes. You input a medical scan, the AI outputs a malignancy score of 92%, and absolutely no one, not even the engineers who designed the neural network architecture, can tell you the exact sequence of the millions of microcalculations that occurred in the hidden layers to arrive at that specific 92%.
Which is an absolute non-starter if that black box is deciding your medical treatment.
Exactly.
Or if it's an algorithm deciding whether you get approved for a mortgage.
It is structurally unacceptable for high-stakes societal functions. So the mechanical pivot outlined in the source material is forcing the AI to generate feature attribution alongside its output.
How are they doing that?
Tech companies are deploying secondary models, techniques like LIME or Shapley values that audit the primary model.
Okay, wait. Break that down for us. How does a secondary model audit a black box?
It essentially reverse engineers the decision. If the AI denies a loan application, the explainable algorithm analyzes the data pathways and outputs a ranking of the input variables. It forces the system to say, I denied this loan, and my decision was weighted 40% on the applicant's credit history, 30% on their income-to-debt ratio, and 30% on their zip code.
Ah, and there's the catch.
Right there.
If the human auditor sees that the algorithm heavily weighted a zip code, which we know can heavily correlate with historically marginalized neighborhoods, the human immediately identifies the baked-in bias.
Yes.
They can see that the AI used a proxy variable for demographics.
And once you can see the feature weighting, you can intervene.
You can actually fix it.
You can adjust the parameters, retrain the model to ignore zip codes, and re-audit the output. The goal is accountability through mechanical transparency.
That makes total sense.
It is the only way to ensure these systems operate with equity. Trust is the ultimate currency here. If society is going to hand over the logistical keys of our healthcare, our financial systems, and our infrastructure to predictive models, you have to be able to trust the math.
You really do.
And you cannot trust a system that refuses to explain its logic.
But taking that a step further, does slapping a diagnostic readout on a black box really solve the core issue?
What do you mean?
We are talking about models with hundreds of billions of parameters. When you distill a billion microcalculations down to a 3-point summary for a human auditor, aren't you inherently losing the nuance of how the AI actually made the decision?
It's a valid concern.
It feels like we are forcing a hyper-advanced alien intelligence to communicate in toddler-level vocabulary just so we can feel like we are still in control.
That is the crucial tension of the current technological era.
Right.
We are demanding that a system capable of processing multidimensional complexity dilutes its logic into a two-dimensional explanation that a human brain can parse.
Right.
There is a very real debate among engineers about whether true explainability is mathematically possible without crippling the model's performance.
Wow. Pulling back to look at the massive landscape we've mapped out today, this snapshot from May 3, 2026 is just staggering.
It really covers a lot of ground.
We started by looking at the raw mathematical power of AI in healthcare, where multidimensional voxel analysis is catching the microscopic signatures of cancer long before human biology can register them.
Right, but we also saw the extreme friction of trying to plug that futuristic architecture into legacy hospital systems.
Exactly. And from there, we traced that same pattern recognition architecture as it inverted itself to generate entirely new, subjective works of art.
challenging our historical definitions of creativity.
and forcing us to ask if the value of art lies in the human struggle of its creation or the emotional resonance of its output.
Huge questions.
Huge. And we anchored all of that in the underlying engine of training data, examining how historical statistical biases embed themselves into the feature weights of these algorithms.
Yes.
We've seen the push for explainable AI, the desperate engineering effort to force these massive black boxes to show their work and prove their equity. It touches the literal cells in our bodies, the art in our culture, and the foundational fairness of our societal systems.
It is a complete architectural shift in how human civilization processes information.
It really is.
And as we conclude this deep dive, there is one final, highly provocative thread regarding this push for transparent AI that I think builds on the source material.
Oh, I love these.
It is something for you to mull over long after we sign off.
Let's hear it.
We have discussed the absolute demand for explainable algorithms, the mandate that an AI must break down its logic to human auditors to maintain trust.
Right, the secondary auditing models.
Yes. But we know these models are scaling exponentially. They are mapping correlations across millions of variables simultaneously, discovering statistical truths in the data that humans couldn't map in 1,000 lifetimes.
Okay.
So consider the concept of epistemic opacity.
Epistemic opacity.
What happens when an AI successfully complies? It explains its decision-making process flawlessly, but the underlying mathematics are so advanced, the logic so multidimensional, that the human mind simply lacks the cognitive capacity to comprehend the explanation.
Oh, man. That completely shatters the dynamic of oversight.
Exactly. If the machine outputs a mathematically flawless 10,000-page proof explaining why a specific patient scan is malignant, but no human doctor alive can understand the math, who is really holding whom accountable?
You ask for the transparency, the machine hands you the blueprint,
Yeah.
and you still have to take it entirely on blind faith because you just can't read the language.
Precisely.
That completely redefines the concept of trust we just spent this whole time analyzing.
It forces us to question the ultimate limits of human oversight in a post-human intelligence landscape.
Well, on that slightly dizzying but incredibly profound note, we're going to leave it there for today.
It's a lot to think about.
It is. Thank you so much for joining us and taking this deep dive into the mechanical forces reshaping our reality.
My pleasure.
We highly encourage you to keep exploring these concepts. Look into how machine learning architectures and data sets are being integrated into your own industry. Stay curious, keep questioning the mechanics of the tools around you, and we will catch you on the next deep dive. Take care.